Welcome to The Explainer. Today, we're taking a deep, inside-out journey through the absolute technological revolution that is happening right now inside modern vehicles. We constantly hear about electric motors and battery ranges, but the true frontier of automotive innovation, it's actually algorithmic. We're looking at a massive transformation where your car isn't just a machine anymore. It's becoming a conversational assistant, a highly vigilant observer, a high-speed neural network, and ultimately a moral decision maker. So let's dive right in by planting a seed in your mind. I want to pose a life or death question that algorithms are literally being programmed to answer right now. Picture this. Your autonomous vehicle is driving along, and suddenly, the brakes fail. It has to make a choice. Does it hit a group of pedestrians, or does it swerve into a solid concrete wall, directly endangering you, the passenger? It's the classic trolley problem thought experiment, right? But as we're going to see today, engineers and ethicists are actually writing the mathematical formulas to solve this in the real world. Keep that scenario in the back of your mind, because by the end of this explainer, you're going to see exactly how the math is written to make that exact choice. All right, here is our roadmap for today. First, we'll look at AI in the cabin. Then we'll explore what happens when cars watch you. Third, we'll lift the hood on the vehicle's neural brain. And finally, we will tackle the ethics of crashing. Okay, Section 1, AI in the cabin and your new conversational co-pilot. We are moving way past the days of hitting a button and stiffly commanding your car to, call John. Take BMW's new Alexa integration that they showcased at CES. This is a brilliant example of the leap from those clunky memorized commands to a fluid, cloud-based generative AI. You can now just talk to your car and issue really complex, multi-part commands naturally. For instance, you could literally just say, "Hey, route me to Mount Charleston, add a CVS stop for sunscreen along the way, and change the driving mode to sport," all in one continuous breath. The system processes those requests sequentially in the cloud, and it even understands vehicle-specific constraints, like it can actually explain to a US driver why local regulations won't allow it to remotely roll up the windows. It's incredibly smart. But getting to that truly ambient AI co-pilot does come with some pretty hilarious growing pains. During development, BMW noticed that customers naturally just dropped the "hey" prefix anyway. They just wanted to use the brand name. So the car now just listens for the word BMW. Well, the problem there is if you're just chatting with your passenger and casually mention how much you love driving your BMW, boom, you accidentally trigger the assistant right in the middle of your conversation. It's just a really fascinating, kind of funny look at the hurdles of designing these seamless ambient experiences. Moving on to Section 2, when cars watch you. AI monitoring systems. So now that the car perfectly understands what you're saying, we're flipping the script. The car is actually watching you back. And why is it doing that? Well, because human limitations, whether that's fatigue or just getting distracted by our smartphones, account for over 80% of road accidents globally. 80%. That staggering statistic is exactly why the newest driver monitoring systems are evolving. They aren't just beeping to warn you anymore. They are actively trying to understand your physical state. To actually fix this danger, researchers are using a super advanced, lightning-fast visual AI model called YOLO V8. And this thing is intense. It doesn't just check if your eyes are open. It categorizes 11 incredibly specific actions. It knows the difference between you texting, reaching into the backseat to grab something, applying makeup, or nodding off at the wheel. By combining distraction and drowsiness detection into one single lightweight neural network, the car basically gets a real-time, comprehensive understanding of exactly what you were doing in that driver's seat. And get this, it does all of that with a 99% accuracy rate. Plus, because this AI model is so highly optimized, it doesn't even need to send your video feed up to the cloud. It operates right there on the edge devices within the vehicle itself, which is great for privacy. If you glance down at your phone or start to fall asleep, the car knows it instantly and can trigger life-saving interventions right then and there. All right, Section 3, the vehicle's neural brain, the Xuanji architecture. So how does a vehicle take your complex voice commands, monitor your behavior in real time, and actually, drive the car all at once? Well, we have to look under the hood at BYD's newly unveiled Xuanji architecture.
BYD describes this as essentially an integrated brain and neural network for the car. It takes all of that localized data, your cabin commands, the monitoring camera feeds, all the external sensors, and it seamlessly perceives environmental changes as they happen. It takes this massive influx of data and processes it in literally milliseconds, allowing the central brain to adjust the vehicle's state instantly. It's a total game changer for both safety and ride comfort.
And having this integrated brain unlocks some absolutely wild capabilities. It utilizes an AI large model that covers over 300 distinct vehicular scenarios, which means it continuously adapts to its environment. All that computational power is exactly why BYD became the first auto brand to get an L3-level intelligent driving test license in China. That means the car can fully handle driving tasks in certain conditions while you entirely take your eyes off the road. But honestly, the most jaw-dropping feature powered by this new brain? It's the world's first vehicle-integrated DJI drone bay. Literally, with just one click, the car's brain manages an automatic sequence to swap a battery, charge it, and deploy a high-definition drone straight from the roof of the moving car. It's just a perfect showcase of what a centralized vehicular brain can actually coordinate. Which brings us to our final section, Section 4, the ethics of crashing, or algorithmic morality. So now that we know the car's brain is processing literally everything inside and outside the vehicle, we have to ask, how does it decide what to do in the absolute worst-case scenario? We're circling back to that gripping thought experiment from the start of the explainer, the real-world trolley problem. When a collision is mathematically unavoidable, humans react with panic and instinct. But an autonomous vehicle? It reacts with code. That means engineers literally have to pre-program ethical choices. How on earth do you quantify the value of human life in a line of Python or C++? Well, engineers have proposed what's called an ethical decision-making, or EDM, algorithm. It maps out a grim, multi-step mathematical calculation that a car has to perform in a fraction of a second during an unavoidable crash. The car isn't just guessing, it's following a highly strict, logically consistent legal and ethical framework. Let's actually break down step by step how this algorithm makes that life or death choice. Okay, step 1 is calculating dynamic survival rates for everyone involved using machine learning. The system looks at the vehicle's speed, the exact point of impact, whether people are wearing helmets or protective gear, and critically, their age. It recognizes that different demographics have varying physical vulnerabilities. Step 2 applies something called Rawls's maximum principle. Instead of doing cold, simple math, like sacrificing one person just to save 5, this principle forces the algorithm to protect the most vulnerable person in the scenario. It ensures that minority groups or highly vulnerable individuals aren't just treated as disposable numbers for the quote-unquote greater good. Finally, in step 3, the system checks if that calculated survival rate falls below a specific safety threshold, determining if the impending damage is fatal or non-fatal. And that threshold brings us to the final crucial calculation. Using Robert Alexi's weight formula, which is actually a framework rooted in German constitutional court decisions, the algorithm weighs a victim's constitutional right to life against another victim's right to health. So, if the math shows that swerving will cause fatal injuries, infringing on someone's right to life, just to protect someone else from non-fatal injuries, infringing on their right to health, the system actively overrides that and prioritizes survival. It's literally providing an objective, mathematical way for an AI to balance competing constitutional rights in real time. Now, you might be thinking, is this just theoretical philosophy? No, the results are actually measurable. In simulation testing across 9 incredibly hazardous scenarios, we're talking encountering school buses, ambulances, crowded sidewalks, this ethical algorithm reduced the total loss of life by an average of 24%, compared to traditional models that just count the raw number of casualties. So by programming the AI to legally weigh outcomes, it is actively saving more lives. As our daily driving experience shifts from just playing with voice-activated comforts and roof drones to relying on AI that watches our every move, we are crossing a really profound threshold here. We are building machines that are capable of, and honestly required to make, moral calculations. So I want to leave you with this final thought today. As the math proves it can actually reduce casualties, is society truly ready to hand over the balancing of our fundamental constitutional rights to a line of code? Thanks so much for joining me on The Explainer today, and keep questioning the technology that drives us.